see on TV as far as weather presentations. I know that the ham radio operators are probably very familiar with the National Weather Service and what we do and why we do it, and law enforcement people and others, but I'm going to go over some of it again because I feel like there's probably some of you here that are maybe not all that aware of what we're all about. It's the National Weather Service's mission not only to write forecasts and various other routine things, but our primary concern is severe weather and the protection of the people. And we try to do this in a number of ways. Yearly, when hurricane season comes up, we hear a lot about hurricanes, and then you're getting the information by the news media as it's being tracked by the National Weather Service, by the National Hurricane Center, which is a part of the National Weather Service. And so there's a lot of information that comes out of primary interest to those that live in coastal areas about hurricanes. For the rest of us, there is a center as well, the National Severe Storms Forecast Center, which is a part of the National Weather Service, that issues severe thunderstorm and tornado watches. And they are located in Kansas City, Missouri. Like I said, they're part of the National Weather Service. They have a large staff, and they break that down into 3 shifts a day, 24 hours a day, 365 days a year. So that it's always staffed with a crew of meteorologists. They're watching the atmosphere for certain things so that they can issue these watches in advance. Then you have Weather Service forecast offices, such as ours, such as the one in Little Rock, that have responsibility for issuing warnings. And we, in the Memphis office, have warning responsibility for the 10 northeast counties of Arkansas, 8 of the northwest counties in Mississippi, and all of West Tennessee. So you can see we have quite a large warning area. The ham radio people have heard us talk for some time about a new radar that's coming and some things that are going to be changing. I'm going to talk a little bit more about that in a little bit. And some of you may have heard about it or read about it in the newspapers as well. There is some changes coming. And one of the things that the change in technology is going to do is maybe even increase the number of counties that we have warning responsibility in. So you can see that along with the technology, there's pluses and minuses. But as in the past, and also in the future with this new technology, we will always need trained storm spotters. The technology is not quite good enough today to do what we would like to do. Certainly we'd like to be able to stop these storms if we could, but we know that we can't do that. So the next best thing is to get out warnings to the public as quickly as we can. And our main focus, the main tool we have, is trained storm spotters. We rely very heavily on ham radio groups such as yourselves, on law enforcement, fire department personnel, and other emergency type personnel that work for city and county and state governments. We all combine together to try to give the public as much warning as we can. And so that's the purpose of a group like this, is to provide that training so that we can get accurate reports in to our office and get the warnings out accurately. Because there is a problem in overwarning. If we was to issue warnings based on false information or information that was not quite accurate, and too many of these things go by, pretty soon people are going to start saying, well, that's just another warning, nothing's going to happen, it didn't happen the last time. And that's the time when the really big one comes. The tornado that, instead of missing the town by 10 miles, comes right through the middle of town. So it's very important to minimize false warnings and maximize good warnings. And that's the slides that I want to show. Again, as I say, I know that a number of you are here for the first time, And I have a couple other films that maybe would be best for you to have seen the first time to really give you a good indication as to what a group such as yourselves are about. But I'm going to show these slides and talk, and then show a film. And after the film, we'll take a break. And if anybody has any questions for me, they can ask me either during the break or then after the next set of films. Feel free to ask questions, and I'll try to answer them. Or TV weather presentations, but this information has to come from somewhere, and it does come from the National Weather Service. And there's a number of things that we do in order to provide the information. At airports and a number of other locations throughout the country, we take surface observations, which is reported hourly and sometimes more frequent than that. It all goes into, I'll talk about two different centers, the Hurricane Center and the Severe Storm Center. But there's also a center, a National Meteorological Center in Suitland, Maryland as well, that collects all this information and provides it not only to other National Weather Service offices, but also eventually to the news media as well. But what's going on at the surface is dictated by what happens in the atmosphere above us. And so there has to be a way of measuring that. Well, we've seen satellite, and satellite is a fairly new thing. The first weather satellite was put into outer space in the early 60s. And if you think about that, you can see that the satellite technology is relatively young. There's been a number of advances since the early 60s, though. One of the primary ways we have getting information about the upper air is by what's called a radio song. Basically, this is a small weather station. It does a number of things. For instance, in this unit right here, this outrigger has a temperature sensor. Within the top of the box here is a piece of equipment that measures the moisture. These are sent electronically down inside here. And this, by the way, is what the fellow's doing now, is getting the battery ready for this instrument to go. And on the inside is a pressure cell. And when it gets it all prepared and ready to go, and by the way, these observations are done at 100 stations across the United States. Little Rock and Nashville are the two closest to us that do it. But from all of these going in, and they all do this at the same time, between 6 and 6:30 in the morning and between 6 and 6:30 in the evening. So they're done twice a day. All this information is fed in. This is where the upper air charts and stuff that you see on the TV at night, where they show the jet stream and sometimes upper air wind flow. That's where the information comes from. Once the instrument is prepared, this is the instrument sitting out here, it is attached to a balloon, a large balloon that's filled up inside here, and it's filled up with either helium or hydrogen, and is carried aloft. This is a parachute that's attached, so that when the balloon breaks, it'll let the instrument back down to Earth safely. And you turn it loose and track the balloon. Now, like I said, it has a pressure sensor, and it has a temperature and a moisture sensor. And then there's a dish up in the dome here, much like what is like a radar dish, only it continuously receives. It tracks the instrument. And from the direction that the instrument travels, we can also tell what the winds are doing, the wind direction and the wind speed are doing aloft. And so this is the initial steps taken, not only in the daily forecasts that are presented, but this also points out areas where the atmosphere is likely to be unstable, and is what is used by the National Severe Storm Forecast Center in trying to predict areas where severe weather is likely to occur. The information is fed back into an office such as this, and they use a mini computer to figure it up. It used to be we had to work up the run, type in the winds and what was going on, but now this person no longer is here. The information is fed back into the computer directly, and it's all deciphered by the computer and then sent into another computer. So it'll go on to Suitland, Maryland. This is what a radar screen looks like in a dark National Weather Service room. Some of the folks in the room here have seen this before, but most of you haven't. And so you can see that it looks a whole lot different than what it appears on the TV screen when you see it when you're watching TV, and it shows all the different colors and everything. Now, like I said before, there is a change coming. The current technology that we're using today is based on technology from the 1940s that was upgraded in the mid-1970s. But now, in the early 90s, there's new technology coming. One to enhance the upper air program, and the other one is for our weather surveillance. We're going to have much more sophisticated weather radar, and it will have, and the police officers in the room here are familiar with Doppler radar, because it gives you an indication of motion. And that's what our Doppler weather radar is going to do. It's going to give an indication to us of the wind currents coming toward and away from the radar site. Therefore, we can pick out a circulation within the cloud, oftentimes before anything does develop. The problem is, right now, is what we call a mesocyclone. Basically, it's like each thunderstorm, in fact, is a small low-pressure system itself. And so those that are intense enough to have rotation, the rotation will show up, but this does not necessarily point out whether or not a tornado is there, whether or not a tornado actually will form. So there's a lot of things that we have to learn about this radar once we get it in Memphis. It's been undergoing tests in Norman, Oklahoma for about 8 or 9 years now, but we have to get it in Memphis to see how it's going to operate. This is what an operator working at a current day radar scope looks like. And there's a number of things that we can do with the radar. For instance, if we see a particular storm, say up in this direction here, he can stop the antenna rotation, point it directly at that storm, and there's a knob over here where we can raise and lower the antenna, and it gives an indication of that one particular storm here. So we can tell how high the storm is, whether or not there's indications of strong inflow wind into that thunderstorm. So there's a number of things that we can do with the current day radar. And of course, you've seen satellite before, and this is just a picture of the global view that we get from space at times. But like I say, the satellite is an important tool to us as well. But there's a problem with it in that each time we get a picture from outer space, it's already 30 minutes old. So in the case where severe weather and weather is developing very rapidly, a picture 30 minutes old is not a lot of good to us if something forms right in our warning area. This is what a typical weather office area looks like, where an operator works his forecast or receives phone calls or issues warnings from a unit like this. Okay, this is a kind of a flow chart. The warning flow chart shows direction of flow, and you can see that the warning, it can come in and go out by way of NAWAS, which is the National Warning Circuit, where we have a direct link with a lot of emergency management and police units throughout all of our counties. The weather wire is one of the main ways that a lot of AM and FM radio stations, as well as TV stations, get their information. This is a one-way, basically, to the media. Law enforcement, like I say, this is a two-way information. We're in communication with law enforcement personnel. They can call us and ask us information about a particular area. We can give them information. Oftentimes we call them, though, asking for information back. If our radar indicates something there, we want to get information back, what is happening on the ground at the time. And you can see amateur radio. This is very important. One of the things that we do when we have a severe thunderstorm watch, or primarily a tornado watch in effect, is we will call, and some of these very fine folks will volunteer their time and come down to our office. They have a radio already set up there, so they come down and turn the radio on and start trying to get the net up and working, and try to get information in for us. And we try to provide them with information to give back out, but it's a very hectic process at times. But anyway, there's a two-way flow of information here as well. NOAA weather radio, I don't want to skip that because some of you may be seen in the newspaper the past few days where there was a number of NOAA weather radios provided to the community here to go into the schools. The NOAA weather radio is a very vital tool, I think, to the public in that it's a direct communication from the National Weather Service to the public, and not only a good tool for the public to use, but like I say, very, very good idea for schools and law enforcement, fire department stations to have one. Lots of times communications may go down in your area because of the loss of electricity or something. If you have a battery-powered NOAA weather radio, though, you're able to get continuous weather information that's coming out over the NOAA weather radios. And also they have a tone alarm feature on them, so very good tool to use. A little bit of statistics, and this goes from 1916 through 1988. And the main thing I want to point out to you, see up here at the top, and this is not the top 10 any of us would like to be in, but unfortunately we are. But you can see Mississippi leads the way, Arkansas is second, Tennessee is 10th out of the top 10 states as far as having tornado deaths. This is something we really would like to do something about it if we can. This gives us an indication. You've heard that, in fact, I just mentioned a little bit ago that we're heading into our prime time of the year for severe weather, and that's true. As the Earth makes its rotation around, revolves around the sun, and we start warming up north of the equator again. This area here, January, February, March, they bring it a little high, but this area here, January, February, March, is the area most likely to have severe weather. And as the season progresses, you can see in red here, it sort of shifts up into this area, April, May, and June. So you can see we're in here, basically it's April, May, and June is mid-March to late May actually is our prime time. And then as we get on up into July, August, and September, prime time is up in that area. And that's because of the conflicting weather masses that we have. Like I say, as things begin to change, we have a lot of warm air coming in with cold fronts moving, strong cold fronts moving toward us from the west. Therefore, high probability of severe weather in this area. And that's another reason why primarily tornadoes, thunderstorms producing the tornadoes move from some westerly direction to an easterly direction. About 80% of all that occur come from some westerly direction. We've all heard about earthquakes and the Richter scale. Well, there's also a scale, and has been for a lot of years, in measuring the strength of tornadoes. And here's with the weak group of tornadoes, about 63% of all tornadoes fall into this category. This is kind of an old slide, though. I have several old slides. And the one thing it says is a poor watch and warning chances. Well, the poor is probably up to about fair as far as the ability to put out a watch for these types of tornadoes. Warning chances are still not very good, though, but they are improving as well, particularly in areas where we do have a strong network of trained storm spotters. These type rated storms are not all that detectable by the current day technology, but a real good storm spotting group can detect these. In the strong category, about 35% of all tornadoes fall into this group, and no longer is it a fair chance, but we have a very good chance of having a watching effect for the area. Warning chances are fair to pretty good. And then in the worst category here, the violent tornadoes, the good news is only about 2% of all tornadoes fall into this category. And of course, we have a real good chance of having a watch out and a real good chance of a warning, because these would be the type that would, even on our current day radar, would give us the signatures that we would be looking for to the indications so that we could get a warning out. And they vary in size, and you can see this is a rather large tornado. It went 220 miles. It killed 689 people from the southeastern part of Missouri through Illinois and on into Indiana. And sometimes they can be on the ground for just a matter of a few seconds and be very small. This is a picture of Finger, Kansas tornado as the wall cloud initially is visible. And you can watch it as it progresses. Now it's a full-fledged tornado, very strong tornado. And this is, in contrast, a much smaller tornado. This one, though, is an Arkansas tornado. Folks that live we're down here from Jonesboro. That's near Jonesboro in 1984. You see, it looks white, real white, but the other one was dark. Although you can see over in this area to the east, it looks fairly dark underneath the large cloud mass. You see sunlight coming in on these shreds of clouds, sunlight lighting up this tornado. That's why it has a white appearance and there's not a lot of debris in it. Same tornado, different picture. Yeah. But this is what can happen. Destruction from a tornado. And this is what's left in the car.
This is a collection of tornado films intended to introduce severe storm spotters to the visual characteristics and vagaries of tornadoes. The film clips add the element of motion, which has not been readily available in previous tornado spotting training materials. This short segment shows the violent and rapidly changing nature of a multiple vortex tornado. Note the intense rotation of the parent wall cloud, which is filling the frame above the tornado. The photographer was within a mile of the tornado, looking southwest as it approached. This is not the recommended way to view tornadoes. If you, as a storm spotter, find yourself in this position and cannot make a quick exit to the east or southeast, then evacuate the car and take shelter in a reinforced building, or as a last resort, a ditch or low-lying area. Later in time, after clip number 1, this was a second tornado from the same parent storm, evolving into the rope stage near the end of its life cycle. The photographer was again within a mile of the twister, looking southeast. Note the violent rotation and whipping action of the vortex as it tosses debris about. The debris probably consisted of sheet metal and wood, as several barns and homes were struck in this area. From a distance of 5 or 6 miles, we are looking northwest. Note the small clear slot of the rear flank downdraft, or RFD, wrapping around the tornado. The intermittent growth and discoloration of the debris cloud is probably due to the tornado moving across freshly plowed fields and then exiting them to cross grassy terrain. Near the end of the sequence, a wide-angle view enables us to see that the tornado is indeed at the rear or southwest flank of the storm. A secondary dust whirl or weaker tornado is also briefly visible at this time, northeast or to the right of the main tornado. This is the same tornado as in clip number 3, except from within a few hundred yards. As the dust whirl of the tornado first appears to our northwest, note the strong southerly inflow winds blowing through the weeds along the road. Then, as the tornado intensifies and moves across the road, a very dramatic wind shift, the RFD, moves across the photographer's position. These west winds are quite strong. Note how this gust front literally pushes the bottom of the tornado forward or eastward as it moves across the road. Most tornadoes tilt back away from the storm to the southwest as they begin to dissipate, but this one tilts forward. Apparently, the direction of tilt is often dependent on the angle from which the RFD winds strike the tornado. Note the bright, flare-like object seen hurtling towards the tornado. This was a tornado rocket probe. You can see the aircraft that launched the rocket turn away from the tornado to the left. Unfortunately, the rocket had misfired and the data was lost. This is Alfalfa, Oklahoma tornado number 1. Looking west from several miles away, note how the tornado moves quickly northward, then reverses its direction and moves south as it reaches the road. The tornado was probably being influenced by the larger scale thunderstorm mesocyclone or parent tornado circulation. The small tornado rotates around this 3 to 5 mile diameter circulation. alfalfa number 1 dissipated, this tornado rapidly developed in the same area from the large rotating wall cloud about which alfalfa number 1 rotated. This tornado was much larger and produced a very large dirt cloud as it traversed a freshly plowed field. We are looking west. At the point where the film takes on a slight bluish cast, the view changes to further away, but this is still alfalfa number 2. Looking northwest, the camera zooms out to wide angle to reveal details of surrounding storm structure. Note the clear slot of the RFD wrapping around the wall cloud. As the camera pans to the left or southwest, we can observe the rain-free base of the flanking line, situated south through east of the wall cloud and clear slot. Can you find the tornado as this sequence first begins? The same thunderstorm which produced the 2 alfalfa tornadoes also produced this monstrous mile-wide tornado. Looking northeast from about 5 miles away, we see a huge wall cloud above the developing tornado. The tornado at this time was visible as a large debris cloud. A final very short clip shows the Binger tornado, again looking northwest from a similar distance. At this time, the large tornado has more of a condensation cloud appearance. This tornado produced devastating F4 damage on the Fujita scale. At the very end of the film, another dust whirl tornado, that is a gust front tornado or gustnado, is visible immediately south of the F4 tornado. This and the next 2 film sequences illustrate the history of a tornado from birth to death. As this segment begins, there is a wall cloud visible looking west. Rotation is visible in the cloud fragments under the wall cloud. Develops, a funnel descends from the thunderstorm to the ground. Rotation of cloud fragments remains quite noticeable throughout this segment. The precipitation area is occasionally visible to the right or north. This is a continuation of the tornado in clip number 9. The tornado is being photographed from 5 to 8 miles away. During one close-up of the funnel, notice small ripples moving up the right side of the tornado funnel. These ripples illustrate well the strong upward motion present in the tornado funnel. The size of the funnel changes as the tornado goes through minor alterations in its structure. Toward the end of the sequence, the tornado moves behind a tree and then re-emerges. This segment was specifically included to help spotters visualize how a tornado might look with obstructions such as hills or trees in the foreground. The tornado is nearing the end of its life cycle, but it is still destructive. Here it is shrinking into the rope stage before completely dissipating. The tornado footage seen in these film clips was provided by the National Severe Storm Laboratory and the University of Mississippi Storm Chase Crews, operating in Oklahoma in 1981. Other footage in the film clips was obtained by a news crew from KAYS-TV, Hays, Kansas. We owe a debt of gratitude to these people for providing the National Weather Service the opportunity for enhancing the spotter training program.
Type thunderstorms that produce tornadoes, and hopefully from the other film that you saw there, that some of the things that we'll talk about will become a little more clear to you. We'll talk about thunderstorms to begin with. Any morning, along about late April and May and June, clouds along about 11 o'clock in the morning, you may see clouds like this develop if there's enough moisture in the atmosphere. And then whether they ever develop further than this or not depends on the stability in the atmosphere. And the stability is something that we would know a little bit about based on those upper air observations that I talked about earlier. You can see that we went from fairly flat and ragged looking clouds to, in a case like this, large puffy looking clouds. And you can see there's a pretty good bit of development within that storm. Okay, here's another one. Again, you can see the strong extent there is within this large cloud mass. You can see areas here, you can see these bubbles here. This is indicating strong vertical winds. A lot of updraft going on throughout this cloud mass, particularly in here, in the area where there's a couple of pretty good sized domes. And then down in here you can see new development. This is new development beginning to take place. Again, we had the same thing here, strong updrafts occurring within this cloud pretty much throughout. And in this area in particular, strong updraft taking place. And then there's newer development just beginning back toward the southwest. Same thing, this is a large dome of clouds, a lot of rising air motion at this time. Okay, this is the classic look of a tornadic thunderstorm. This is as we're to the south of the storm looking north this direction. There's some things that you can tell about a storm like this if you were fortunate enough to see one standing out all alone by itself. The problem is most of the time there are storms like this embedded in a whole bunch of other clouds, and distinguishing this is hard to do. But there's some things that we know about this from looking at it. Like I say, we're to the south, looking in is north, over this way is west, over toward me is east. And you can see that there's strong updraft taking place within the cloud, and again back in this flanking line there's new development starting and a few puffy clouds on back to the southwest. In this area here you can see how the cloud is just sheared off. What's what goes on in the upper atmosphere, there's, again, you've seen it on the TV, the jet stream, they show the jet stream where it's at, where there's ribbons of air, currents in the upper atmosphere. And what's going on here is there's a very strong horizontal wind coming across in this particular location. There's also horizontal winds maybe from varying directions down below that, but in this area there's a very strong horizontal wind coming across here and shearing this cloud off. So what's happening above this strong horizontal wind, you can see there's a dome punching up way above that. That means that the vertical wind current going up is strong enough that it'll punch right through that ribbon of strong horizontal winds. It'll punch through there, and it causes the cloud to develop in a dome like this. And sometimes this will be 5,000 or 6,000 feet above the strong winds. What happens when that indicates that you have a very, very strong vertical wind, very strong rising currents within the cloud there, and also due to the contrast between the air going up very strongly and the strong horizontal winds, you get a lot of strong wind shear within the cloud. And a lot of us have heard about wind shear, particularly as it affects aircraft, and certainly that's a very important thing, but wind shear is also within the cloud one of the main ingredients necessary for the formation of tornadoes. Tornadoes generally form in the upper atmosphere between 18 and about 35,000 feet up. That's where the initial things start to happen that form tornadoes. Keep the look of this in mind, because we'll look at a couple of schematics here in a little bit and talk about them. Again, you see in this cloud several different areas. This is a cluster storm. There's several areas of very strong updrafts taking place at this time in the development stages. One thing I'd like to point out to you about lightning is, besides the fact it can be harmful to you, lightning is a very good thing to use when you're spotting. If you may not be in the city, you may be out just a little ways, and it's difficult at nighttime, and a lot of the bad weather we get does occur at nighttime. One of the things that you can use is lightning. Look toward where the lightning is occurring. See if you see any of those low-hanging clouds, any of the appendages there, like a wall cloud or a funnel cloud or even a tornado on the ground. That's a very good way of getting light so that you can see what's approaching you. And another thing too, and I've done a lot of investigations after tornadoes have occurred, and another thing that is mentioned quite frequently to me is that there has been a lot of lightning, almost continuous lightning sometimes, in these storms that produce tornadoes. They're usually quite electrifying. Okay, this is a look at a wall cloud occurring here. You can see how dark it is to the east and to the north. And back here, this is the clear slot back toward the southwest part of the storm. And another look at a wall cloud and a circulation beginning on the ground. You couldn't really see anything in between at that time. Again, here's a wall cloud that has formed. You can see it's underneath. There's a strong updraft here, very strong updraft in this area here, just above where this wall cloud has formed. You see how dark it is over this way? There is rain occurring, very heavy rain occurring to the north and east, and it's relatively dry back to the southwest. Okay, this is a schematic view of a tornadic thunderstorm. This is that thunderstorm that I showed just a few slides ago. And this is what it looks like, though, if we were in a helicopter or something up above the storm looking down on it. And then down this way toward the bottom would be south, and up toward the top of the screen here would be north, over toward me is east, and the other direction west. And this large area is that anvil top that I was talking about, that sheared area where the strong horizontal winds blow across and shear that storm off. And so what may happen is, for instance, if you were right here in West Memphis, and before these clouds showed up, and maybe just some of those little puffy clouds that we were talking about a little bit ago were in the sky and nothing else, and you notice that suddenly on the horizon there's a thick mass of clouds at high levels, and it doesn't take but about 30 minutes for that to completely overshadow you, and suddenly the sky is overcast. Then the next thing you might notice is a rush of cool air coming past you. That would be this gust front occurring right here. While this happened, this rain-cooled air, cooled by the strong rain back behind it, is pushing out way ahead. And sometimes the strong air, if it's rushing out fast enough, will cause more instability, more lift, and can indeed create rapid growth of other thunderstorms out ahead of it. In this area here is where the light rain would occur. Moderate heavy rain would come at you next as this thing keeps going past over you. Then you might be in the area where small hail is occurring, and then large hail. If you're in that part of the storm that's receiving large hail, be very cautious, because you're in the part of the storm that's most likely to produce the tornado. That would be right in this area, general area here, where this dark blue is rain-free, basically. And you can see from these bars, it shows the outrush of the cold air, and here, inward pointing warm air bars. What's happening is the storm is drawing warm air into it from the south, or from the southeast. Warm air is being drawn into the storm, into this area, and rising. So in this area, you have rising air. And in all this area here, generally you have descending air coming down with rain. And then you have a strong outflow here, this flanking line down through this part of the storm, and other development will occur. There'll be a line of smaller storms down through here. And what can and does happen oftentimes, say a storm to the southwest of you produced a tornado right here, maybe several counties away to the southwest. And then the storm begins to die out, but the storm system is continuing to move toward West Memphis. And then as this particular thunderstorm dies out, if atmospheric conditions are still right, one of the storms in this flanking line will begin to grow. Just one of them. They'll start taking in all the energy, and it'll eventually become like this storm. And if this storm had produced a tornado downstream, this next one that develops may produce a tornado when it gets up toward your area. So knowing what's going on to the west of you is a very good thing too. Knowing this storm structure is also very good, because it can give you some idea, particularly if you're out in a vehicle somewhere and you're sitting in a vehicle, you're watching, and it's raining very hard, and all of a sudden large hail starts falling down, then you know that you're in a dangerous situation. So you may want to head for a building somewhere. Okay, this is the same storm, only a different view. This time we're to the south of the storm. Looking in would be north, and over toward me again east. And you can see pretty much the same thing we've said before. To the north and to the east, precipitation is occurring. In this area, the wall cloud generally is rain-free, although not always. And then in this area here, more than likely is where the tornado would develop. And here you have the flanking line back toward the southwest. Okay, this is a view. We're standing somewhat to the southeast of this particular storm. You can see the wall cloud as it has formed here, hanging down to the east. This dark area is very heavy rain that's occurring. At this time, you see it's rain-free back in this direction here. And this is one of the storms that was mentioned in the film there, only it's a clearer picture than what they showed. But what we have here is it's pretty well rain-free everywhere from the appearance of it. a large tornado on the ground back here toward the southwest quadrant of this storm. But to the north and east of it, a smaller tornado has formed. These tornadoes are generally much smaller, weaker, and last for a short period of time. Okay, here we have a tornado on the ground. You can see how dark it is underneath the thunderstorm itself, mainly due to the fact that it's being shielded from the light, but also there's probably some precipitation occurring. You can see how light it is back here, the sunlight hitting the cloud from the back, from the southwest side of the storm. Okay, this is a tornado again back towards the southwest quadrant of the storm. It's in the rope stage here as it begins to dissipate. They mentioned in that film clip that we watched that showed that one picture where the tornado was actually pushed way out ahead of where it normally would be. Usually the storm itself is moving at the winds, upper level winds are just pushing the thunderstorm itself, and so the tornado would be on the ground at an angle back toward the southwest or toward the west, some westerly direction, depending on where it's coming from, but it would be trailing along, and sometimes that's what causes the skipping motion. It'll break, and the circulation will start up again a little bit ahead. But the thunderstorm is usually, by that time, is trying to outrun the circulation coming in. But again, that flanking line has a lot to do with the direction and the path and what a tornado does. And indeed, the flanking line can oftentimes do a great amount of damage itself. In fact, sometimes some of the investigations I've gone out on, it's hard to distinguish what part of the damage did the tornado do and what part of the damage did the flanking line do. Again, this is the same thing. We have a tornado on the ground at this location here, very dark to the east and to the northeast, as very heavy precipitation coming down. It's very rain-free back in this direction. In fact, you can see the sky back in this direction very light. Okay, here's another one of the problems we have is tornadoes that occur within rain. It's not always rain-free where they occur. What we have is there's a tornado occurring right here this time, and there's heavy rain occurring all around, so very difficult to see. One of the things that you hear about tornadoes is that freight train sound, and that may be the first tip-off in a case like this. That sound you hear might be the only tip-off that you have that a tornado is there, if you don't get the hail ahead of. But another thing too I'd like to point out though is the freight train sound is not inherent with a tornado. There's other weather phenomena such as downburst or even straight line thunderstorm winds that can produce that same sound. Wind going at 100 miles an hour is going at 100 miles an hour, whether it's caused by a tornado or whether it's caused by a downburst. And the way it's going to sound like a freight train. Okay, again, we have, you see, very clear tornado here, wall cloud. Okay, we have tornado occurring here, wall cloud. From this angle, not all that visible. You can see some of it right in here. You see the debris that's being picked up. Okay, again, on this one we have a very clear wall cloud that's occurring. Tornado to the east, heavy precipitation, and back toward the west and the southwest, the rain-free base. Another thing to watch for in clouds, assuming that you don't see a tornado, but maybe you see what you think. I mean, this is a very distinctive wall cloud here, little doubt, but sometimes, particularly if you're seeing it just as it develops, or if it's a weaker circulation, it may not hang down all that much lower than the cloud base. So the thing to do is watch for signs of rotation, signs where some of the lower fragmented clouds are going in a rotation type motion. These things are very important to us. A report of a wall cloud particularly if you can be descriptive with it, is quite a tip-off to us, and this is what we're looking for. We can issue a warning ahead of time rather than after the tornado has touched down. This is just more of the same. You can see back toward the east and the northeast how heavy the rain is occurring at this time. Even though this appears it doesn't come all the way down there, because it's a flat field, not much out there, probably is in contact with the ground. That's another thing about a tornado is if you see something like this, but the funnel does not appear to be all the way to the ground, watch for debris flying. If there's debris flying, even though there's not cloud all the way to the ground, there's debris flying, there is indeed circulation at the ground. That is a tornado, not a funnel cloud. So report it as such. Report it as a tornado. Just to see destruction going on. And this is a tornado here that's within a rain area. You can see how dark it is over in this area. Very heavy rain taking place. The rain's a little lighter back this way. Fairly light back here, but it is enough to mask this tornado. You have to look very close to see it, and then from here on, rain-free. Okay, in this picture here, there's not a lot that you can really see about it. For one thing, what we have here is this is some little bushy trees right in this area. But you see some low-hanging, boiling, very, very dark, menacing-looking clouds. Other than that, you can't see an awful lot about it, except that you can see debris flying around this time. The next photo shows us why there is debris flying around. And there's no doubt about it now. You see how very dark it is underneath the clouds, a very large tornado. And you can see the circulation going on. But you notice the light back on the southwest part of the outer cloud. This is protected from the light, but light coming in on the back side of the cloud there, so you know back toward the southwest part of the storm. Okay, like I said before, we don't want to issue false warnings, or we don't want to get people headed for shelter any more than what we have to if it's not really occurring. So we want to be aware of tornado lookalikes, and there are clouds that give the appearance. For instance, this is a roll cloud here. It appears that it's going down toward the ground, but it's not. There's a very, very long cloud going down toward the horizon, gives it the appearance of coming down to the ground. But this is not. It's a horizontal cloud, and it's a roll cloud being pushed along, but this will not give anyone on the ground any problems. Okay, in this area here, we have a couple things going on. This area here, you might think this is a tornado. The thing to do is watch it for a while. Watch for rotation. Watch for some signs that there's rotation, or some signs of debris flying or something. What's actually happening here is that this is a very strong area of rain taking place. It's actually bringing fragments of the clouds down to the ground with it. Over in this area here, we have what we call scud clouds, quite a few of them around. And what has happened is there has been rain that has fallen and stopped, but the rain has cooled the atmosphere abruptly, and which in essence has formed these low fragmented clouds down below the main cloud base. Like I say, you see something like this and you're not sure, watch these fragmented clouds. See if they're rotating around on the outer side, rotating around. And what's going on here is this is a strong downburst that's taking place, and that strong downdraft of wind is actually bringing part of the cloud down to the ground with it. These things can be quite destructive in themselves, but like I say, they're not tornadoes. Same thing, strong downburst of, in fact, this is really for you because there's a strong downdraft occurring at this time, and it's curling over this way. And out here to the east is some heavy rain occurring, so this one could pull you quite a bit. Again, this is underneath all these massive clouds. See this area here where you may begin to think that there's a tornado occurring. Watch it. This is just a heavy rain shaft occurring at this time. It's more heavy rain coming down from here. Another heavy rain shaft back in here. It's more of those low-hanging scud clouds in this area. This is another one of those roll clouds. Yeah, it looks quite ominous, and it would be. Again, we have heavy rain back over here to the east, and extremely strong downdraft that's taking place right in here. And this is kind of a close look at downdraft. What has happened actually is back here off of the picture actually is where the downdraft initially came down. And within a downdraft there's two main areas of damage. There could be damage on a long path, but the two main areas of damage is where the downdraft first makes contact with the ground. I mentioned before that downdrafts can be quite destructive. They take roofs off of houses. In fact, in some instances, they have totally flattened houses. But they come down to where they first initially make contact, a lot of damage will occur, and then the wind just spreads out along the ground, goes out in all directions. And as it moves along here, if there was a house or some trees in the way, it could snap the trees off, it could uproot them, it could twist them even, and which would give maybe an appearance that a tornado had occurred. But as it moves along, and then it begins to rotate up in this direction. This is the second area right in here. This is the axis of the rotation. This is the second area where damage is likely to occur because you have a lot of wind shear occurring right in this area. And first hitting it from one direction and back from another direction. So a lot of damage will occur right in there. And then as it spreads out and weakens, you're left with this little bit of circulation that eventually dies out. Have a record of you if you volunteer to be a storm spotter for us. And also I'll use these to have some training certificates typed up showing that you were here and received the spotter training. And then back there on the table, if you didn't already pick up one of these and a Skywarn spotter card, pick them up before you leave. I want to talk to you just a little bit about these. The Skywarn spotter card is pocket size. You can put that in your billfold or carry it in your pocket with you somewhere. On the inside, it gives you two pictures of the schematic that I just showed and talked about just a little bit ago. So you can take a look at these to refresh yourself from time to time. And then on the back, it reminds you what to report, to report what you saw, where, and at what time and by whom. And then the spotter guide is a very good thing for you to look at. You may not want to carry it around with you everywhere you go, but take it home with you and read through it. There's some interesting things in the spotter guide. It gives you information on severe thunderstorms. It has information in here. Again, it has a picture of the schematic that we just talked about a few minutes ago. And it gives information about tornadoes as well. And then on page 12, in particular, has a lot of good information in there for us. Number one, down at the bottom of the page, it says spotter aids. It tells you how to estimate hail size and also how to estimate wind speeds. This is very good information for us because we would issue a severe thunderstorm warning based on 3/4 inch hail or on wind speeds of 58 miles an hour or greater. So estimating this is very good to us. And as you can see from what I was talking about using that schematic, Also, the size of hail, not only would we issue a severe thunderstorm warning based on hail 3/4 inch or larger, but also hail size is an indication as to the intensity of that storm, which will help us as far as trying to determine the potential that storm has for producing a tornado. And then the spotter reporting procedures, please go over those, because I've talked a lot tonight about what to look for and that sort of thing, and knowing what to look for, and like I say, trained spotters are invaluable to us. We need you very badly. But knowing what to spot is only half the battle. Reporting it and reporting it correctly is the other half. And if you see something and you don't report it, or if it gets lost down the way somewhere, then seeing it initially, won't help us as far as getting a warning out to the rest of your neighbors. So report, and it says report briefly what you have seen. Was it a wall cloud, a tornado, a funnel cloud? Was it heavy rain? Did you see damage? Was there tree limbs strewn out across the road, or did you see a large oak tree laying across the road as you drove down the road, or something like that? That's very important, and differentiating between tree limbs, small tree limbs, and large tree limbs. It may have been 40-mile-an-hour winds that knock off small tree limbs, and it might have been 60-mile-an-hour winds that knock off large tree limbs. So a little bit of detail is very good. In fact, a couple of years ago, we got a report from a Tennessee highway patrolman, several counties to the north of Shelby County, called in a report of a funnel cloud. But he didn't stop with the report of a funnel cloud. He went on to say he saw a funnel cloud that was moving to the northeast that had sheets of plywood in it. And that sheets of plywood told us it had been on the ground at one time, and based on what our radar operator was telling us, the storm was still as intense as ever. We issued a tornado warning. It did touch down again, so that was a very excellent report that we got from that highway patrolman. By the same token, though, the same summer, we did have another bit of a problem, which would be covered in here, but we got a report also from the Tennessee Highway Patrol as well, from the dispatcher, that said that there was large hail coming down, beating the roof in, and she was located on Summer Avenue. So our forecaster, and there was a thunderstorm over Memphis at the time, so our forecaster issued a severe thunderstorm warning based on that report of large hail. But as it turns out later, she was relaying a report from the southern part of Tipton County. A patrol car was getting the roof beaten in by large hail, and we issued a warning for the wrong county. So just a little bit of clarification can make a big difference. Where you saw it occur at, or where you saw the damage, if that's what you saw, very important. And when, the time that you saw it, if you see damage occurring and call it in, also say, I saw damage occur. It occurred in the southwest part of West Memphis, and it occurred at 10 p.m. That's very important to us, because another thing that happens is, particularly in the case where damage has occurred, the reports sometimes will continue to roll in for 30 or 40 minutes, and sometimes, particularly if there's other storms coming along, it's hard to distinguish between is the damage still going on right now, or is this an old report from what we had previously. And so this is very important as to whether or not we would, we don't want to issue another warning for that same area that has been damaged if it doesn't need one. And the what you saw, report what you saw, very important. Like I said, if it was a wall cloud, or if you saw a funnel cloud. Another thing too, if you see what you think is a funnel cloud but you're not sure, call it in, but identify it that way. Say, I think I saw a funnel cloud. Identify yourself as a trained storm spotter, for number one. Or if you're on the ham radio, those folks already know, you know how to talk to one another, so you don't have to worry about that. But if you're not on ham radio, say you're a member of the public and you see something, you call it in for the sheriff's department, inform them that you're a trained storm spotter and what you saw. Ask them to relay the information to the National Weather Service. And like I say, report what you saw, when you saw it, and the time. And that about finishes it up for me. Does anybody have any questions at this time? Yes, sir.
Mr. Lane, in Whitehaven, Elvis Presley and Range had a tornado several years ago, and no definition of the funnel at all, but it was picking up the sheet metal, and you could see it firing up.
Mm-hmm.
And does this happen in city areas quite often, that you won't see the funnel? You just see, like you mentioned, plywood from the highway patrolman.
At times,
you see the sheet metal, but that be, if you see sheet metal sailing, you wouldn't ordinarily think that as a tornado.
Yeah, that can happen. And whether or not it has a cloud all the way to the ground or not, though, like I say, that doesn't really mean a lot. The strength of the tornado usually will dictate whether or not the strength of the tornado and is whether it has a moisture source or not has a lot to do with that. In fact, this last film I want to show, and I will talk a little bit during the film, very little, but you can kind of see a little bit about how these things do. In fact, the tornado goes through several stages. At some points, there is a distinguishable cloud all the way to the ground. At other times, there's no cloud visible at all. So that's not necessarily always inherent within the city limit or whatever, but it can happen at any time.
One other thing, as a child, I heard of cyclones, and what happened to them, and why did
Nothing. It's all the same thing. Just the terminology depends on what part of the country you live in or used to live in. And a cyclone is really a broader term. Even a hurricane is actually a cyclone. It's a cyclonic circulation. And tornadoes have been called cyclones and twisters and tornadoes and maybe a number of other things. It's all the same thing.
Thank you, sir.
Yes, sir.
Could you give a good definition of a wall cloud?
Good definition of a wall cloud. Wall cloud is an appendage, a cloud that hangs lower than normally than the rest, or at least lower than the main cloud base, and is normally in rotation. There's some evidence of rotation. That the tornado, as was mentioned in that first film that we watched, the tornado actually formed within the wall cloud, and the reason why it made that U-turn was because it was in that larger circulation that was taking place within the thunderstorm itself. Yes, sir.
In flying with, well, in weather where it's always running into roll clouds at the same time.
Roll clouds?
Yeah.
No, roll clouds is not the same thing as a tornado.
Well, wall cloud and roll cloud.
A roll cloud is a little different. No, a wall cloud is a cloud that hangs down due to the circulation within the thunderstorm as rising currents are going.
It is not at the roll in
Right.
front of it.
A roll cloud is actually rolling due
yes, I
to
know
the
that,
translation of the thunderstorm. Yes. Okay, I'm going to show this other film. I want to explain a little bit about it. It's about a tornado that hit in Minneapolis, Minnesota several years ago. It's very dramatic footage in that it lasted for about 35 minutes, and a news crew flew up in a helicopter and continued to circle the tornado and got about 30 minutes of footage. And I have 13 minutes of that footage on the film that I have here tonight. So it's got very dramatic footage and gives us a very good opportunity to take a lengthy look at one tornado. But one thing that I am a little bit disappointed about is the Weather Service paid to have it done, but they did not have a Weather Service person or even a trained storm spotter to do this. They had the fellow that's in charge of the parks area in Minneapolis do the narration. So he talks about this, does a good job talking, but the main problem I have with trying to show it to a group of spotters is the terminology that he uses. He calls this tornado a vortex, which that's correct, and he calls it a tornado, which is correct, but he calls it a funnel cloud. And he calls it a funnel cloud a lot more than he calls it anything else. So please, if you folks see a tornado, don't call us and tell us you see a wall cloud or a funnel cloud. And keep that in mind that when he's using the term funnel cloud, he's using it incorrectly in this film. So I'd like for you to be cautious of that.
was a late Friday afternoon when a tornado suddenly struck 8 miles north of downtown Minneapolis, Minnesota. The presence of a tornado rarely is documented as dramatically as these views from a helicopter. Saya St. Clair, director of the Springbrook Nature Center, was there when it happened.
The first photos that are actually going to show the funnel cloud right here. The funnel cloud is not across the Mississippi. It's still on the west side of the Mississippi River and is moving almost due east towards the Mississippi at this point. The next shot that shows it from a different angle, it will actually be crossing the Mississippi River and entering a park. Right here is entering a park on the east side of the Mississippi River. We're looking due west here. You can see parts of a picnic shelter being demolished as it crosses the river and enters the park here. This is not inside the Nature Center yet. This is a small park that is right alongside East River Road, Kennedy Park in Coon Rapids, Minnesota. The tornado is approaching East River Road at this point, moving east, going through a number of large trees. The debris you see in the sky is parts of that picnic shelter coming down right here. You'll see 85th Avenue to the right of the screen here. That's a flash on East River Road of power poles. 85th Avenue is the north boundary of the park. That's another power pole, small power pole, telephone pole on East River Road as the vortex is crossing East River Road here and entering a field just south of 85th Avenue and approaching the park. The park is the bottom of the picture on this side of the power poles that you see. There's railroad tracks there. There's an advertising sign to the right of the vortex, right by the road. The advertising sign and the exchange guards for the railroad tracks are going to be destroyed here in a few seconds. Then the vortex will move across the railroad tracks into the power poles, and you'll see the flashes as the tornado actually enters the Nature Center area and actually turns one of the large high-tension power poles from its base. Right there's the first wire, then you'll see 2 more wires go. We have ceramic pieces of the ceramic insulators that were on the wires that were blown up as a part of that were left laying at the bottom of the pole. The helicopter here is looking southwest right now as it comes down around. You can see debris. That's a large wood chip pile that we had at the base of those power poles where we stored wood chips for the park. The helicopter is moving west, looking almost due south right now. The tornado is going to be moving slowly due east alongside 85th Avenue, but inside the park about 50 yards. We're moving up on a little knoll and staying there for about 5 or 6 minutes. There's to the right or to the left of the screen, there's biotechnology factory, Endotronics, whose roof is going to start to come off in about 30 seconds. It is on the other side of the road. Those flashes that you saw are from the telephone lines that run alongside 85th Avenue. You'll see the insulation styrofoam pieces coming out of the roof. Now that's about 100 yards away from the actual vortex that you can see. As we're moving here, we're looking southeast here and are swinging around so that we will be looking due east in just a few seconds. Here comes the parts of the roof off of Endotronics. You can see the white debris coming from the left of the screen. Some considerable distance, about 100 yards away from the vortex. There you can see the building there on the left. There's another power pole going that's on the small one on 85th Avenue. You can also see water vapor crossing 85th from the right, more water vapor coming both from the right and the left from ponds within the park. The white debris that you continue to see throughout the next 10 or 15 minutes here is from the roof of Endotronics. You can see the small knoll that this is staying on. There were no trees left on that at all. It just sits there for quite a little while. That was a mature aspen forest up in that area before the tornado hit. It's going to start moving slowly now, due east, down into the beaver pond that we have there. There's about a 100-foot section of in-place boardwalk that will be ripped up. It starts to go up right here as the vortex moves across the pond. The trees that were on the north side of 85th Avenue were completely taken out here, the ones on the extreme right of the stream, as well as what was underneath the vortex, what appears to be the vortex. Now the center of the vortex moves fairly quickly, about 200 or 300 yards, into the picnic area and the parking lot of the Nature Center. The trees that you see being taken out there right in the parking lot area of the Nature Center. You can see here in a minute as the view swings around to we're looking southwest right here, coming around to look due south. There's the parking lot right underneath the vortex of the tornado. You'll see a picnic shelter just to the right of the vortex, where all the picnic tables were completely taken out from underneath it. They weighed about 300 pounds apiece, but the picnic shelter wasn't hit at all. There's a small car you can see there right underneath the vortex that was completely demolished. There's about another 130 feet of boardwalk right now that's being taken up. You can see pieces of it starting to come down. You're going to see the vortex enter a small field and take a cherry tree, about a 50-foot cherry tree that was out in the middle of that field. Here in a second, there it goes right there. Now the funnel is going to stay. It'll move over into these aspen area here and take all of these aspen trees out, and it's going to come back into this field and move back and forth across the field several times, and eventually actually dig a hole about 2 feet deep and 10 feet across right through the middle of the field. You can see that happen here in just a second. You can see the dirt as the funnel cloud turns brown. It's right here. The Nature Center building is to the extreme left of the screen. You can see how close it came. The staff person, a young woman who was in the building with several volunteers at the time, and this is an underground building, most of it. They were in the underground part. Their ears popped 3 times while they were in the building, and from that, the people that we talked with had decided that the actual funnel cloud passed over the building 3 times. The vortex is now entering a large oak forest that we had, about 40 acres of it within the park. We lost a total of 40 acres of forested area. This is all mature oak forest with trees that are about 75 feet tall. They're all about 150-year-old oak trees. Although the funnel cloud seems to sort of dissipate as it comes into these trees, it seems to be more for lack of material, because this is where it did the majority of its actual damage to the park. Through this entire area, and about for the next 8 minutes that the tornado was in the park, even though it doesn't look like it's doing very much, there was out of thousands of trees, just a rare occasional tree that was left standing. None of those were really left whole. There may have been 30 trees that were left out of this whole area. Now the vortex, although you can't see it here, is taking out some of the large cottonwood trees that were off to one side of the oak forest. They were about 90 feet tall. We measured these trees after the tornado was over with tapes. You're looking almost due east here. University Avenue is at the top of the screen. And we swing around and are perpendicular to it there. Now you're looking due east. Now the helicopter is swung around and it's looking northeast a bit. The funnel cloud, what little of it you can see, did some of its worst damage right in this spot, right in here. There were very, very few trees left. This is in the extreme southeast corner of the park. University Avenue and Northtown Shopping Center are in the upper left, or upper right rather. Small shopping center due north of the Nature Center. Springbrook Mall is in the upper part of the screen here. None of these buildings that were immediately south of the tornado, some of them within 150 feet, none of them were touched at all, nor any of the vehicles. This is University Avenue looking northwest here. You can see the trees in quite a large area here are all bent down. While it looks like they're into a smaller tree area, all of the trees in this entire area are about the same size. These are all mature oaks, and a lot of cottonwoods in here that are between 75 and 100 feet tall. This is the end of the film right here, a few last shots of the funnel cloud up in the sky.